Okay, so hello everyone. Today we'll be solving the LeetCode 75 problem, which is can place flowers. Okay, so this is the video of our playlist in which we are solving the 75 questions in LeetCode, just LeetCode 75. Okay, so now let's see what the problem is. The problem number is 605. It is marked as an easy one. This is the problem name, and now let's read the description and understand what the problem says. Okay, so you have given a long flower bed in which some of the plots are planted and some are not. Okay, however, flowers can be planted in adjacent plots. Okay, given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty. Okay, and integer n and an integer n is given. Okay, return true if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule, and false otherwise. Okay, so what the problem is saying that we have been given an array of flower bed in which there is a rule that the flowers can't be planted adjacently. Like if you plant a flower here, you can't plant it here. Like no adjacent flowers can't be can be planted. Okay, and we have given an integer n. We need to tell that if we can plant all these n, like plant all these n into this flower bed or not. Okay, so if we can, we return true. If we are not able to, then we return false. Okay, so now as we can see, the constraints are good, like the constraints are very high. Now let's see what the solution is. Okay, so we are given a flower bed. This is the flower bed array which is given. This is the end, so we need to plant one flower in it. Okay, so let's see. We start iterating, like at here we can see it's planted, so we can't plant. Okay, now here we can plant, like because it's 0, but there is an adjacent flower already planted, so we can't plant here. Okay, now we come to here we can plant, and if we check on the left and the right hand side, there is no adjacent flower planted. So what do? We plant here, we decrease the value of n, which will become eventually 0 in this case. So our new flower bed will look something like this. Okay, we have one flower. These are the old ones, like you can see these were the default, they were already planted. We have planted this one. Okay, so as n equal to 0, so we have, which means that we have planted all the flowers, so we can just simply return true. Okay, so if n equal to 0, n is less than equal to 0, we can return true. Okay, so now there's another example. Now let's see how the trident works in this case. We again start from here. As we can see, 1, so there's already a flower planted, so we can't plant it. Here we can plant, but if we look adjacent to it, like here we can see a flower is already planted, so if we plant here it will violate the rule, right? So we move to the next index. Now next index at here we can plant because it's 0, and if we look adjacent to it, like here and here, there is no flower planted. So what do? We can plant it here. So our flower bed will look something like this, and we will decrease the value of n, which will become to 1, right? Okay, So now let's start iterating again because n is still equal to 1. Okay, we come here, we can plant here, but look, adjacent element to it, it's 1 here and 1 here. So we can't plant it, right? So we move to next index. At here we see that a flower is already planted, so we still can't plant it here. And then we will go the, like, if we have iterated all the flower beds and we weren't able to place this one flower. Okay, so if n is less than equal to 0, we return true, else we return false. So the n is 1 and 1 is not equal to 0, so we return false here. Okay, so that's a simple like that was a simple dry run. Okay, so we can check it. Like, there are some edge cases which I will tell you in the code. So now let's come to the code, right? So okay, first we calculate the size of the flower bed. Okay, so we start iterating. Okay, so now see here, if flower bed of I, like, if we can plant it here, we check. Okay, so the first condition we check that if it's at the index 0. Okay, so we have some special conditions here. Why? Because let me show you. If we're at index 0, we can't check the left adjacent. Okay, so we need to manage it. We need to manage this. Okay, so for it, we have managed it here, right? If we have managed it here, and then so what about this else if condition? This else if condition is in the case of when we have only one element. Okay, only one element, then this will run, like, because if we are coming here, then I plus 1 must be greater than or equal to size, because it must like it must not obey this condition, then only we come to this. Okay, so yeah, that was the ith part. And similarly we have to check for the, let me just show you in the code, like the last element. Like, if suppose the flower bed was empty here, it was 0, so we can't check that adjacent element to the right, so we need to check only to the left. So this else if covers that part. And else if this is in the general case, like if it's somewhere between, then we check it. Okay, so see, the condition is same, like we are just subtracting the number of decreasing the number of flowers, and we are putting 1 to that place. Okay, see, all in all the cases we are doing the same thing, only the edge cases need to be covered in this question. Okay, so at the end, if we just return n is less than equal to 0, which will, if it will be true, it will be true, it will be written as true. If it is false, then it will be written as false. Okay, so that's the question. And as you can see, we have successfully run it, and we have a time complexity here, which is like what? Big O of n. It's an n solution, and we aren't using any extra space also. So yeah, that's a good solution for it. So yeah, that's all for the question. You will find the question link and the solution link in the description. Okay, so have a nice day, everyone. Okay, so yeah, that's all for today.